Hi guys! In this lecture video, we'll learn how to draw the Lewis structure of an ionic compound by using the Lewis dot symbol that we have learned from the previous video. So we have seen already that the Lewis dot symbol allows us to understand how electrons are transferred to produce the structure of an ionic compound. And here in this case right here, we'll go over the Lewis structure of the ionic compound in great detail. And we'll also learn how to write the formula of an ionic compound as well. So we can see that for each ionic compound, we can draw its Lewis structure by focusing on only its valence electrons. And once we have drawn a Lewis structure of an ionic compound, it can show us how electrons are being transferred. It also helps us explain and predict the charges of the ions. And it also allows us to write the formulas of the ionic compound that are being produced. And here are the steps how to draw the Lewis structure for an ionic compound. First, draw the Lewis structure of the metal and the non-metal. And again, in order for us to have an ionic compound, we need to have a metal interacting with a non-metal. And next, we will then determine how many electrons that the metal need to give up in order to achieve an octet of electrons. And then we'll also determine how many electrons that the non-metal must gain to achieve octets as well. And then, based on the electrons that the metal must give up, and electron that must gain by the non-metal, we will then determine the ratio between the metal and the non-metal. So that way, the electron will be balanced out. And this ratio right here will then be used to write the formula of the ionic compound. And we'll see that in a little bit. And then we will then transfer the electron from the metal to the non-metal. And then we will then write the corresponding Lewis dot structure for the ions that are being produced and their charges. And we also use the bracket to show the electron ownerships after electrons are being transferred already. And now, here is an example right here to make sure we understand and know how to follow all of this step. So first, the ionic compound between sodium and chlorine. So here in this case right here, we can see that for sodium, a Lewis dot symbol is Na with 1 dot. And for the chlorine, it is Cl and it has 7 dots. So what we have done now is just complete the step 1. And now for step 2, we need to determine how many electrons that the metal must give up to achieve an octet. And here in this case right here, we can see that sodium has 1 valence electron. So I'd like to give up 1 electron. So give up 1 valence electron. As for the chlorine, in this step 3, we can see that it needs to gain 1 electron in order to achieve an octet. And because sodium would like to give 1 and chlorine like to gain 1, therefore in 1-to-1 ratio, that is how they can have a balanced amount of electron. So in this case right here, when sodium and chlorine are interacting, they are interacting 1-on-1, because in 1-on-1, that's how the electron will be balanced out. And now with the next step, we will then transfer the electron from the sodium into the chlorine. And the resultant structure would then be sodium. And now, without any valence electron, it will then become positive. And as for the chlorine, it will now have 8 valence electron. And notice one of the electron, the extra electron now they have this gain from the sodium. And here in this case right here, for any atom that has valence electron around it, we would then put it inside a bracket to show all the electron in here belong to the element. And now we put the chart outside. And in this case right here, the chlorine is now becoming -1. So there you go. And this would then be the Lewis structure of this ionic compound. So whenever we ask students to draw the Lewis structure of an ionic compound, this is what we are looking for. And we should also be able to write the formula of this ionic compound as well. And in this case right here, the formula shows the ratio between the cation to the anion that would then produce a neutral substance. And in this case, because sodium is +1 and chlorine -1. So in 1-to-1 ratio, that's how they are neutral. So therefore the formula would then be Na1Cl1, or simply this NaCl. And now let's go over more information about the formula of the ionic compound. So ionic compound are always neutral overall. So therefore they need to have the ratio between the cation and the anion. This ratio need to be adjusted in such a way that the charge will be balanced out and the compound will then be neutral. And a neutral collections of ions, that's what the formula of the ionic compound would be. And we refer to it as a formula unit. So if we were to be looking at a structure of a piece of sodium chloride crystal, we will be seeing a lot of alternating cations and anions that are stacking on top of each other in this three-dimensional shape. So to figure out what would be the formula of this ionic compound would be, we will then pick out a repeating ratio that would then produce a neutral collection of ion. So overall it be neutral. So here in this case right here, it does not matter how we take a look at it. We can see this in one way how it can be repeated, and this is another way how it can be repeated. But then the repetition that create a neutral collection of ion would then be 1 sodium for every 1 of the chlorine, and that is known as the formula unit. So the formula unit is the smallest whole number of repeating ratio of the ions present in the ionic compound that result in the charge being neutral. So here in this case for NaCl, it would then, for sodium chloride, it is NaCl. And that is formula unit. Now, nearly all ionic compounds are solid at room temperature due to the strong attractions among this particle right here. So that's something important for us to remember. Most solid are actually solid at room temperature because each of these particles right here are strongly attracted to each other due to the fact that they have opposite charges. So, and this basically fit into the description of what the solid state would be, that they have strong interaction among the particles. And now let's try another example how to draw the Lewis structure of an ionic compound and write in the formula. So in this case, let's do this 5A together. And so go ahead and please pause this video and try this problem first before we go over the answer key together. And now let's go over this problem. So here in this case right here, how would we draw the Lewis structure of this ionic compound? Then again, start by drawing the Lewis dot symbol of the calcium and the chlorine. So the calcium has 2 valence electrons. And again, please remember that the 2 electrons are in the same orbital. So we need to put this electron together. And in this case right here, the chlorine has 7 valence electrons. So those would be the Lewis dot symbol of both of this element. We will then see that for calcium, it is a metal and has 2 valence electrons. It needs to give away 2 electrons to achieve an octet of electrons. So therefore, we see that calcium would like to give up 2 valence electrons. And as for chlorine, right now it has 7 valence electrons. So it like to gain 1 valence electron. Because every calcium would like to give 2 electrons away, and it won't be happy if it doesn't give up 1, because just by giving up 1 electron, it will not have an octet of electron. It like to give up 2. But now chlorine just like to gain 1. So in this case, and chlorine cannot gain 2 because when it gains 2, it will not be happy either. So here in this case right here, we will then see that calcium and chlorine will not be interacting in a one-on-one basis, because that would not make them happy. So in the end, there has to be 2 chlorine that would interact with every 1 calcium. So therefore, we have to put in another chlorine. So we need to have 2 chlorine, and now each chlorine will be accepting 1 electron from the calcium. So the calcium would not be happy, and both of the chlorine will be happy. So therefore, that's the ratio right there. 1 of this to 2 of this. So keep that in mind, so that way we can write the formula in a little bit. And now, let's now transfer the electrons. So one of the electrons from calcium will be transferred to this chlorine, and the other electron will then be transferred to this other chlorine. So in the end, we can see calcium would now without any valence electron, and now become positive 2. And as for the chlorine, each of the chlorine would now have an octet of electron, and we become negative 1. So that would then be the ionic, the Lewis structure of this ionic compound. 1 calcium, that is positive 2, and 2 of the chlorine, each is negative 1. And each of the chlorine then has 8 valent electron. Now we can simplify this drawing. Anytime we have repeated of something, then it's quite redundant for us to keep on drawing it. So therefore we can combine it together, and by doing the following. Put the cation first. So again, always put the cation first, and now we have 2 of the chlorine. So therefore, and each of the chlorine has 8 valent electron, and is negative 1, and we need to have 2 of it. So therefore, we put the subscript 2 outside, and this will say for every 1 calcium, there are 2 of this chlorine, and each of this chlorine is negative 1. So this is the Lewis structure of this ionic compound, and this is the simplified structure. We can either keep it in this format or this format, but sure hope that you realize that this is actually a better one, since it's less time consuming to draw it. And as for the formula of this ionic compound, it shows the ratio between the metal to the non-metal, what that will result in the charge being neutral. And we can see that right now for every 1 calcium that is plus 2, we need 2 of the chloride that each is negative 1. So therefore the formula would then be CaCl2. And in this case, we write this as a subscript. And that subscript right there is indicating the 2 chlorine. And that's the formula of this ionic compound.